Hello everyone. In the last video we spoke about finding the rule when I have the gradient and 1 point on the line, and we said that these are the 4 steps that we followed. We substituted m into y equals mx plus c, then we substituted values for x and y from the point, and we used that to solve for c. So then we had a value for m and a value for c, and we could put those in to write our full equation. And this was the example that we did. We found the equation of the straight line passing through the point -1, 2 with a gradient of 3. This was the line that we found, and following these steps we found that the equation was y equals 3x plus 5. In this video now I would like to do the last finding the rule scenario that we're going to be presented with. So this is finding the rule part 3. And if you think about a straight line, any 2 dots on a graph can be connected, and if I just have 2 dots and I connect them in a straight line, then that'll create a linear graph, right? So the third part of finding the rule is if I have, I guess, the minimum amount of information that I could be given that I can use to form a linear graph. And that is, I'm going to find the rule when all I have is 2 points on the graph. I've got 2 points on there, that's all I've got, and I'm going to use that to find my whole equation of y equals mx plus c. The steps that I'm going to follow to this are very similar to the ones that we did last time. So it's almost identical to these steps, except that there's an extra one. I can't substitute m into y equals mx plus c in this situation because I'm not given m. So it's exactly the same as this one with an extra step first, which is to find m. So I'm actually just going to write that down. I'm going to say that to do this, it's exactly the same as when I have just a gradient and 1 point. Except that the only difference is I have to find m first. Okay, so how are we going to do that if we're given 2 points on a graph? So we're just going to introduce a bit of notation. If I've got 2 points on a graph, that means, let's say, for example, I could have, I don't know, we've got for the point 4, 7 and the point -1, 2. Let's just say. Okay, these 2 points on the graph, I'm going to give these a generic notation. If I've got 2 points, then in this point, this is my x value, this is my y value, this is my x, this is my y. So I'm going to call, in my first point, whatever number falls in that slot, I'm just going to call that x1, and this is going to be y1. And for my second coordinate, I'm going to call whatever's in that value x2, and whatever falls in that slot, y2. So this is my first coordinate with x1, y1, and this is my second coordinate with x2, y2. And to find m, let's think back to a couple of videos ago. M, which is the gradient, equals the rise over the run. So it's how much have I risen from 1 point to the next, divided by how much have I gone across the graph from 1 point to the next. And there's 2 other ways that I'm going to write that are going to help us solve these types of questions. The rise. How much do I go in the vertical direction when going from 1 point to the next? So I'm going to think about that as this. Now, we haven't introduced this symbol yet. All it means, it's the Greek letter delta, and it just means the change. Okay, so delta y is how I would say that, and it means the change in my y values. So going from this y to this y, how much has my y value changed? What's my change in y? That is my rise, and I'm going to divide that by, of course, the change in my x value. So I'm just writing that as another way to think about rise and run. Rise is how much does my y value change, and x is how much does my x value change. Another way of thinking about that, or writing that, the way that's going to be the most helpful for us when solving these questions, is how do we calculate the rise, the change in my y from y1 to y2? Well, I'm going to take my second coordinate y value and minus my first coordinate y value. y2 minus y1, that'll give me how much have I travelled up from y1 to y2. And it's the same thing with change in x. I'm going to go x2 minus x1, and that's going to give me how much have I run across the graph from x1 across to x2. Okay? This is a rule that I'm going to use when I'm finding m. Once I've done that, I can then follow these 4 steps that we did in the last one, because I now have m, so I can just run through the way that we already know how to. Okay, let's do an example. Let's say I get given this question. Find the equation of the straight line which passes through the points 3, -1, and 5, 2. Okay, so this is my x1 and y1. That's my first coordinate, x1, y1, and this is my second coordinate with x2, y2. Just to show you what's going on here, I'm going to start by plotting these on the graph. So this is just going to be a bit rough on this rough set of axes that I've drawn. This first point is the point 3, -1, and this second point is the point 5, 2. Let's say it's roughly about there. Okay, so the first thing I need to do is find my gradient. So I'm going to join up these points just to show you what I'm doing. This is the straight line graph that I'm going to get. And it's always helpful to do that because it gives you a quick idea when you get an answer of whether you've got it right or not, because if it looks like it's wrong, then it generally is. Okay, let's think of what's the gradient of this line. Well, it is, like we said on the last piece of paper, y2 take y1 over x2 take x1. In this case, for my y's, I'm going from -1 to 2. So y2 minus y1 divided by x2 minus x1. What does this equal? Well, 2 minus -1, so minus and negative is the same as adding, so that's 2 plus 1 is 3, and 5 minus 3 is 2. Okay, and I could write that as a 1.5 if I wanted to as well. Now I'm just going to go through the same steps that we did last time to get my full equation. So I've got, this is my value for m, so let's write it out. Y equals 1.5x plus c. Now I'm going to take an x and y value to substitute into this equation to find out what my c is. Now, in our last, the last one we did, where we were finding the rule in this case, it didn't really matter which x value, we didn't have a choice of which x value to use because we were only given 1 point. Whereas here we have a choice, but it doesn't matter which one you use as long as you keep it consistent. So if you're using this coordinate, then use the x and the y value from this coordinate, and if you're using this one, use the x and the y from here, but it doesn't matter which coordinate you use. Okay, I'm going to use, which one should we use? I'm going to use this one, so I'm going to say y is 2, which equals 1.5 times 5 plus c. Let's now solve for c. So c2 equals 1.5 times 5 is 7.5 plus c. Therefore, c equals 2 minus 7.5, which equals -5.5. And that roughly matches up with what we found over here when we drew the graph. And now the end of the process, I'm going to write out my equation in full with everything that I've found. Y equals mx plus c, which is 1.5x minus 5.5. There we go.